Alright, in this video I wanted to talk a little bit more about Boolean theorems. This time we're going to talk about the consensus theorem. Actually, there's multiple of them, the consensus theorems. The consensus theorems are going to give us 4 more theorems here. Theorem number 16 states that if we have x or not x and y, we can simplify that down into x or y. Theorem number 17 says that we have not x or x and y, we can simplify that down into not x or y. 18 says that if we have x or not x and not y, we can simplify that down into x or not y. And if we have theorem 19 says not x or x and not y, we get not x and not y. So basically, when you've got something that looks like this, you're going to pull this first guy out and you're going to use whatever that y is like normal, and you'll get rid of this guy in each of those. Okay, so that's how we're going to use that. Now we're going to go over just another quick example using all the theorems that we've learned so far to try to simplify this guy down the best that we can. So if we've got this function here, function 4 is p and s, or p and not q and not s, or p and q and s. Okay, so the first thing we're going to do is we're going to use theorem 14 to throw some parentheses on there to make this a little bit more workable. So we take theorem 14, we use theorem 14, it's going to give us something that looks like p with the parentheses, s or not q and not s, and then we're going to leave that last one by itself, p, q, s, just like that. And then we're going to use our theorem 18, which we just learned. Looks like x or not x and not y. Should give us something that looks like, actually it tells us that s plus not q, not s is equal to s or not q. So that gives us this p ended with s or not q, or p and q and s. Then we're going to use theorem 14 again here to pull that parenthesis back apart, so that gives us p and s, or p and not q, or p and q and s. Then theorem 14 again, change our stuff around here a little bit. If we pull ps out of this guy, we can have 1 plus q plus p and q here. It's supposed to be a not q. Then we use theorem 6. We have that guy. We know that 1 plus q is just going to be, or 1 or q is just going to be equal to 1. So if we go back over here, that gives us ps and 1, or p and not q. Yep, and then we use theorem 2 to tell us that p, s, and 1 is going to be equal to ps. So that gives us a final answer F4 of PS or P and not Q.